Hello everybody, welcome back to a new lesson. In this video we're going to talk about thermodynamic processes, and then we're going to solve section review of the section 3. Then let's start. We have thermodynamic processes. We have isovolumetric. Isovolumetric happens when there is no change in the volume of the system. And no work is done by the system or on the system. So here, work is equal to what in isovolumetric is equal to 0. A note that you have to know is isovolumetric mostly happens in a rigid body, okay? When you're talking about isovolumetric, we're talking about a rigid body, or we are talking about a constrained system where there is going to be no change in the volume of the system. We have isothermal. Isothermal happens in a constant temperature, and there's no internal energy changing. So delta U is going to be 0. A key note that you have to remember is that isothermal happens very gradually or slowly. We have adiabatic process. Adiabatic process happens when there is no energy transferred. Okay, why there's going to be no energy transferred? Because it happens very rapidly. Okay, adiabatic process happens very rapidly, and there will be no time for energy to be transferred. An example of isovolumetric process is a bomb calorimeter. You basically have a sample burning here. You have a sample here, and this container is filled with water. Okay, this container is filled with water. When this sample burns, it's going to transfer heat to the water. Then we're going to calculate how much is the change in the temperature of this substance. During this process, there's going to be no change in the volume of this container that we have. So a bomb calorimeter is, as we have studied this in the section 2, is what is an example of isovolumetric process. We have an example of isothermal process. Basically, when a storm approaches, the pressure outside decreases. Okay, if you have a balloon like this, if a storm approaches, the pressure of course outside decreases, and then when the pressure decreases, the balloon is going to what? The balloon is going to expand, and because there is no external pressure pushing on it, so the temperature here is going to be maintained constant. The balloon absorbs heat from the surrounding air, and then the balloon is going to have what we call a balanced shape as it gains heat from the surrounding air. Remember, isothermal happens very gradually, and temperature is going to be constant during the expansion of this balloon. We have an example for adiabatic process. So adiabatic process, as you remember, happens very rapidly, and there is no energy transferred to or from the system. You have an example like this. When a gas rapidly escapes from a compressed tank, so this is a compressed cylinder, a compressed gas here is a cylinder. So when the gas escapes from this cylinder, it expands very quickly, and there is no time for the heat transfer to the surrounding. Okay, as you remember, we mentioned that because adiabatic happens very rapidly, there's going to be no time for the heat transfer. And as a result of this, the gas is going to cool down, and then do work, okay, as internal energy. So internal energy basically here is going to do work. This is an adiabatic process, an example of adiabatic process, and volume here is going to be what? Volume is going to be constant, okay? We have section 4.3. In which of the following situations listed below is energy being transferred as heat to the system in order for the system to do work? In which situation is work being done on the system in order for energy to be transferred from the system as heat? So first of all, we have two sticks that are rubbed together to start a fire. So basically here, work is done on the system. on the system. This is work done on the system. Firecracker explodes. This is work done by the system. Work done by the system. We have the last one. A red hot iron bar is set aside to cool down. So this one is going to be work done by the system. Now if you ask why, okay, by the system. First of all, if you rub two sticks together to start the fire, you're basically doing work on them, okay? You are moving them and you are causing a friction. So you are doing work on the system. When a firecracker explodes, it's going to affect the air, okay? It's going to make the air around it hot, okay? So a firecracker is doing the work. So system here is doing the work. So work done by the system. If you have a piece of iron which is really hot, okay? This piece of iron is going to transfer heat to the surroundings. So here, the iron is going to do work on the surroundings. So work done by the system, not on the system. It's not the piece of iron that is getting hot. It is the piece of iron that is transferring heat to the surrounding. Identify the following processes as isothermal, isovolumetric, or adiabatic. So first of all, we have a tire being inflated. A tire being rapidly inflated. So you have the word rapidly. So this is going to be what? This is going to be volumetric. Sorry, this is going to be adiabatic because we have the word rapidly. So adiabatic. A tire expanding gradually with heating. So we have the word gradually. This means that this is what? This is isothermal. A tire being heated while in a rigid metal container. So this is a rigid metal container. Remember we said that if it's a rigid body or a container that is constrained so that there will be no volume change. So this is what? Isovolumetric. We have question 3. A mixture of gasoline vapor and air is placed in an engine cylinder. The piston has an area of 7.4 times 10 to the power of minus 3 meters squared and is displaced inward. So by 7.2 times 10 to the power of minus 2 meter. So first of all, we have area, which is equal to 7.4 times 10 to the power of minus 3 meter squared. Is displaced inward. Here it says displaced inward. So this is the reaction. If imagine you have, for example, a cylinder like this, or let's say this is an engine cylinder, and this is the direction of the displacement. So it's going inward, meaning that it's compressed. So distance is going to be what? It's minus 7.2 times 10 to the power of minus 2. If you say, why do you put the minus? This is because it is compressed. The displacement is inward, not outward. And remember, we said if it's compression, if the gas is compressed, then it's going to be we are going to have a negative result. So this is going to be minus 7.2 times 10 to the power minus 2 meter. Then the pressure is equal to what? Pressure is equal to 9.5 times 10 to the power of 5 Pascal. It says how much work is done during this process. So work is equal to what? Okay. Is work being done on or by the gas mixture? Let's calculate this. So work is equal to what? Pressure multiplied by delta V. We don't have delta V, so pressure work is going to be pressure, area multiplied by distance. This is going to be what? Pressure is equal to 9.5 times 10 to the power of 5 Pascal times area is equal to what? 7.4 times 10 to the power of minus 3 multiplied by what? Multiplied by minus 7.2 times 10 to the power of minus 2. What's going to be the result? The result is going to be 5.1 times 10 to the power of 3 joule and minus, okay? Or 5 point, you can get these are the same, it's just written in scientific notation, 506.1 joule. It's the same, okay? Now we got a negative result. What does this negative result show? Work done on the gas mixture, careful. on the gas mixture, not by the gas, but on the gas, because we got a negative result. We have question 4. A weather balloon slowly expands as energy is transferred as heat from the outside air. If the average net pressure is 1.5, so pressure is equal to what? It is equal to 1.5 times 10 to the power of 3 Pascal. And the balloon's volume increases by 5 so volume, because you only have one volume, so this is going to be delta V. And it says the balloon increases by 5.4 times 10 to the power of minus 5 meter cubed. How much work is done by the expanding gas? So we already know that the gas is expanding, so this is going to be work done by the gas. So work is equal to what? It says what thermodynamic process is this? Is it isovolumetric? Is it isothermal or adiabatic? Let's calculate this. Work is equal to pressure multiplied by delta V. Pressure is equal to 1.5 times 10 to the power of 3 times. Then we have what? Delta V, 5.4 times 10 to the power of minus 5. Work is going to be equal to what? 8.1 times 10 to the power of minus 8 joules. Now, we have a positive result. We know that gas is doing work and gas is expanding. But which thermodynamic process is this? It says what? The balloon slowly expands. So which process is going to be? It's going to be isothermal, since it is slowly expanding. This is it for today. See you in the next video, and we will be solving chapter review questions.